Polyatomics. They can be fun. Now last year, the polyatomics basically stayed together. If I had an OH on one side, I was going to have OHs on the other side to balance. If I had a PO4 on one side, I would have PO4s on the other side to balance. So I could just keep the polyatomics stuck together and treat them like they were their own element, which is how they act. However, in this year, you're going to be having to be a little bit more careful. Now with this question, this is the example on the bottom of page 108 and goes over to page 109. And it gives you a bunch of polyatomics. So what you want to do is look on one side and see if they're the same on the other side. NH4 is not here. It's become NH3. So we can't just balance the NH4s, obviously, because they're not on both sides. We'll have to balance the N's and the H's separately. PO4, however, there is a PO4 here and there's a PO4 here. There's no other phosphoruses anywhere here, which means that the ratio of phosphorus to oxygen is going to be linked together. That means we can balance PO4 as just PO4 instead of P's and O's separately, which is kind of handy because it's just one less piece to move around. So I've listed NH, PO4, Na, and O on both sides. And we're just going to go through and decide how many of each we've got. So I've got 3 N's because this means that I've got 3 of everything that's in this set of brackets. So 3 N's here. And my hydrogens, I have to be a bit careful because I have 4 inside the brackets and there's 3 of each of those groups of 4. So I have 12 here and 1 over here. So that gives me 13. It's an odd number. It's probably not going to stay that way. PO4, I just have 1. Na, I have 1. And free oxygens not attached to the PO4, I have 1. I go to this side, my N's, 1. H's, I have to be careful because I have 3 H's here and 2 there. Make sure that you count them all. PO4, I have 1. Na, I have 3. And oxygen that's away from the PO4, I just have 1. So some of them match, many of them don't. I don't want to start with my hydrogens and oxygens because they're kind of broken up everywhere. I'm going to choose what we call a major, which is one that is a little more specific, a little more rare. Now, an easy one to begin with here might be sodium, because all I really have to do to balance the sodium out is to put a 3 here because I have 3 sodiums on that side and just 1 on this side, so that changes this. What it does as well is change my oxygens and my hydrogens, so I'm going to have to adjust that as I go. I have 3 oxygens that aren't attached to the PO4 on this side, and I've increased from 12 plus 1 to 12 plus 3. So that's given me 15 hydrogens on this side. But my sodiums are balanced. Hydrogens and oxygens I'll worry about afterwards. Next comes nitrogen. Now I've got 3 nitrogens on this side and only 1 on this side, so I'm going to put a 3 here. That's going to change that to a 3, but it also changes my hydrogen. So I'm going to change my hydrogen to go with it. 3 times 3 is 9, plus these 2 gives me 11 hydrogens. So I go down my list, leaving the hydrogens for now. I've got an oxygen here that's O3 on this side and only 1 on that side. And there it is. So if I put a 3 here, that's going to balance this guy out. So now all I'm left with that isn't balanced is my hydrogens, but I just changed those when I did that. So let's reconfigure. This is still 9 hydrogens here, but this one is now 6 hydrogens. So in total I have 15. So I've played with a bunch of the numbers. I'm going to just do a double check from the top and see how we're doing. 3 and 3, 15 and 15, 1 and 1, 3 and 3, 3 and 3. Hey, it's balanced!